All right, continuing from the previous lecture, we're going to just talk about the other two quantum numbers. So quantum number 3 is known as the magnetic quantum number. And the symbol for this is a M with a lowercase l. So it's M subscript L, okay? What this value determines is the specific 3D orientation in subshells. Remember, coming from the value of L for subshells that contain more than one orbital. Okay, I'll mention this briefly. So remember we said for values of L, we had 0, 1, 2, and 3 are the ones that we really talk about. And then the subshells associated with this are S, P, D, and F. We're going to find out from the quantum numbers that the number of orbitals in this particular type of subshell will be 1 orbital in an S, 3 in a P, it's going to be 5 in a D, and it's going to be 7 in an F. Now, of course, the final thing that we could say here is therefore the number of electrons in the subshell. Therefore, remember, it's 2 electrons per orbital, means that the number of electrons in an S subshell is 2. The number of electrons in a P subshell is 6. The number of electrons in a D subshell is 10. And the number of electrons in an L subshell total is 14. Still 2 electrons per orbital, but total number of electrons per subshell. Okay. So going back to, we were talking about M sub L tells us the orbital in the subshell. The numeric values, therefore, are going to be minus L passing through 0 up to positive L. Another way to say this, I think, as your book does, is M sub L, absolute value, is less than or equal to plus or minus L. Okay. Very briefly to look at this then, if you have an electron with an N value of, say, 4, this gives you L possible values of 0, 1, 2, and 3, because remember, it is N minus 1 is the largest, highest value of L. Then our possible M sub L values are -3, -2, -1, 0, 1, +1, +2, +3. Okay. Good so far. I'm going to end this lecture very briefly right here, and then we'll move on to the next one.